Hi everyone, myself Deepak Chaurasia. I'm pre-final student here at IIT Kanpur and summer intern at Maritime Research Center as a research engineer. So my project title is Sediment Transport Modeling in Brahmaputra River. Let's get started. These are the content slide that we will be going through in upcoming slides. First of all, starting with the what is sediment. So, starting with the definition, sediment is basically particulate matter or kind of silt, clay, gravel that mobilize or moves with the flow of a river during their movement. And next, we will go to the type of loads that we usually see in sediments. First is suspended load. It's a very fine particle that flow with the river. It consists of roughly 85 to 99% of the total sediment that we study for a river. And second is bed load. That is a much heavier load that settle down at the bottom of the river. And third is wash load. Basically, it's a subset of suspended load, but it's a very fine particle, more finer than the suspended load. And third is impact. In upcoming slide, we will be seeing those impact about the navigation, reservoir capacity, infrastructure health, and ecological habitats and maritime means marine life. So, what is sediment modeling? Means what the things are we going to do in the in sediment modeling? Basically, it's a numerical simulation or physics-based method of uh, uh, in which we study about the eroded sediment, silt, clay, gravels transported by a river by flowing the river during their flow, both including suspended and uh, sediment load. And of course, there is an application. That's why we are going to do modeling. The application include predicting channel aggregation, and second is optimizing dredging so that we can predict the where the sediment deposition is more or less, and we can optimize the dredging. And the dredging erosion and control. It is also helpful in prediction of a flood for a particular river and accessing the habitat changes and of course the health of infrastructure uh, uh, and its impacts. So why we are doing sediment modeling? Basically, we are predicting the channel evolution, shoaling, score, and bar migration. And second is dredging optimization, as we talked in the last slide. Means like by predicting our sediment, um, we can predict the where should we dredge, where is the sediment more and where is the sediment less, so that we can optimize our dredging. And third is flood risk assessment due to the uh, heavy settlement of a sediment in the bed of a river. We can access the means the flood risk means the uh, and third is sustainable management reservoir sedimentation and forecasting the health of infrastructure and delta health. So let us come to the means why it's matter for our Brahmaputra. So as we know that Brahmaputra is means one of the longest river in northeast, especially in Assam and Arunachal Pradesh, and it's one of the highest sediment containing river. Means approximately around 700 metric ton to 1000 metric ton, both including suspended and bed load. And this is way higher than any other river exist in India in compared to sediment. And second is gradient morphology, frequent bar formation, and third is monsoon dynamics, extreme flood that may be risk particularly in Assam's and Arunachal Pradesh, and socioeconomics importance, of course, flood navigation system and infrastructure like hydropower and even for the agriculture impact on the Brahmaputra. As we can see in the graph that suspended sediment concentration increases in the monsoon as compared to dry region, even from the compared to Indus River. For our Brahmaputra case is always increasing. We can see in the bar chart as compared to Athens and Indus River. Even Times is also saying that means like Brahmaputra has very variable sediment, so modeling is very important. Uh, here I have list down the some states of some river that I have studied during means what are their sediment load, as compared to Brahmaputra. If you will see the Brahmaputra, that is way higher than any other river like Mahanandi and Bhagirathi Hooghly in the Kharke and Tel sub-basin. That is, Brahmaputra has 700 plus, but none of the river even has 500 plus except Hooghly, that is roughly around 520 in the max case. And third is, here are the different models that have been studied and applied on the different river for sediment modeling. First is and For our selection of a model, first is Mahanandi India. They have used on our sedimentation modeling. Bhagirathi Hooghly Hecrus 1D model they have used, and in Indus Pakistan they have also used Hecrus 1D sediment model, and Kharke Iran they have used MKE 11 SD STCC 2ED model, and Ethiopia field measurement analysis they have used, and in Mississippi USA they have used Hecrus 2D model. And first of all, criteria for my model selection for Brahmaputra cases, basically two things I have kept in mind. First is the model that we are going to select, their their sediment amount or bed load should be equivalent to the Brahmaputra as means as roughly equal to 200, 300 or 400. The Second is model should be as much as open source, so that we can take the references and tweak that model for our Brahmaputra case. So keeping in those two things in mind, we have finally selected Hecrus 2D model, and we'll be going through Hecrus 2D model for the our sediment modeling. So by Hacker Studio model, of course, it's free and open source, license free, and it's we are comparing 2D sediment modeling, 2D modeling of means flow of a river, not 1D, and easy onboarding and prototyping and tweaking is also easy for Hacker Studio model, and it has been already used on a Hacker's Hooghly River, but it was 1D, but we are using 2D so that we can capture more for Brahmaputra gas. And here are the key data that we are going to need for our modeling: geometry and topographical data. Uh, Second is hydrological forcing data, morphological parameters, and sediment properties like their grain size and bed sample and bulk density and critical field parameter. And third is roughness and land cover, mannings and maps, bank, floodplain, vegetation, and cover. And a Hacker's model, here is my workflow: first gathering the data and then imported to, then creating the 2D mesh, and then of course linking the all hydrograph data to our model, and then predicting the sediment amount of sediment that we are going to map. And here are the expected outcome that we are expecting from our model. So first of all is sediment budget. Of course, we are doing sediment modeling. Then we will have a sediment model, sediment data of time series and annual loads. And second is drilling and infrastructure advice. On the basis of if we have a sediment data, then we can advise the government or optimize the dredging on the basis of where the sediment load is more and where the sediment deposition is more. Then we can optimize our dredging for the health of our infrastructure and flood risk management, management, and even for the marine life and protection, bank protection, and preventing from erosion of river. And third is flood risk assessment. Of course, if there will be more sediment deposition in a riverbed, there will be increasing of the risk of flood in those particular area that is surrounding those beds of a river. So we can predict the flood risk by modeling the sediment. And fourth is sustainable management, or predicting the infrastructure health and forecasting, and even the delta health, and even for the marine life, the fishes they are living in the river. If there is high sediment, that will also be problem for them. And thank you.